Hi, I am Dr. Shubhangi Vaikore, working as a associate professor in computer department at Dattamegi College of Engineering, Airoli. Now today we will see the second chapter of Artificial Intelligence and Soft Computing. The second chapter is the problem solving. This chapter is all about the problem solving agent, what is the working of problem solving agent, then how to formulate or how to describe the problems, then the example problems. Then in this chapter we'll also see what are the various searching techniques. There are various searching techniques such as uninformed search techniques and the informed search techniques. Then there are also the optimization algorithms or optimization problems are there. So in this video, we'll cover the first topic of the second chapter, that is problem solving agent, formulating problems and the example problems. Now, first we'll see solving problems by searching. Now, reflex agent is simple. We have already seen what do you mean by the reflex agent. So based on the matching between the if and then conditions, the reflex agent takes the action. So based on their action on a direct mapping from states to actions, but cannot work well in environments which this mapping will be too large to store and will take too long to learn. So this is basic limitation of the reflex agent. Here the mapping will be very large and it will take more time to learn because the size is very large of that lookup table. Hence, the goal-based agent is used. To solve the particular problems, we prefer the goal-based agent as compared to the reflex agent. So it is problem solving agent. The problem solving agent is a kind of goal-based agent. So in the goal-based agent, we see the internal state of the problem also and we consider the goal also. It solves the problem by finding sequences of actions that lead to desirable states, that is goals. So we can give here the example as suppose we are moving in a taxi and if there are three ways, we can move to the left or right or we can go straight. Then first of all it is observed that where is my goal, my destination, or if my goal is present towards the left hand side, then I'll move to the left side. If it is present to the right hand side, then I'll take a right turn. If it is a straight, then the taxi will be moved to the straight direction. So depending on the goals, the actions are taken. So to solve a problem, the first step is the goal formulation based on the current situation. So always when the problem solving agent is executed, its very first step is the goal formulation and the agent performance measure. So we have to formulate the goal as well as we have to formulate the performance measure. So problem formulation is the process of deciding what action and states to consider given a goal. So in this table, we can see the function, that is the agent program. We already seen what is the difference between an agent function and agent program. Agent function is what? The agent function is just a mathematical description of a problem. And when we convert that abstract mathematical description into a coding or actual implementation, it is called as the agent program. So in this slide, we'll see the agent program for a problem solving agent. So the function name is simple problem solving agent. It takes the input as the percept and returns an action. The static sequence and action sequence, initially empty state, some description of the current world state, goal, initially null problem, giving into this program. We are giving the action sequence. Initially the state is empty, then we are giving the description of the current world state. What is the current scenario, what is the current environment, then what is my goal, what is the problem formulation that we have to give as an input to this function. Then here one more function as update state. So the responsibility of this function is to update the state given the current state and the perceived sequence. And the rules are, if sequence is empty, then what the agent will do, it will formulate the goal based on the given states. Then the agent will formulate the problem based on state and the given goal. Then the agent will search given the problem and the sequence is decided. Then first action is taken, then rest the sequence is followed, and return we get the action. So this is the agent program for the problem solving agent. Now next one is goal formulation. The goal is formulated as a set of world states in which the goal is satisfied. Reaching from initial state to the goal state, action is required. Yes, obviously, suppose we are present at the initial state and we have to reach to the goal state, then obviously we have to follow certain set of actions in order to reach to the goal state from the initial state. Then actions are the operators causing the transition between the world state. Yes, obviously, when we reach from initial state to the goal state, we perform the transition between the states. So one state to the next, then next to the next, and finally we reach the goal. So these transitions are nothing but the actions, and these actions are nothing but the operators. Actions should be abstract enough at a certain degree instead of very detailed. Yes, the action should be abstract to a certain degree instead of very detailed. We cannot give the very detailed information about the action. It should be some sort of the abstractive action. Example, turn left versus turn left to the 30 degree. So turn left 30 degree represent a very detailed, and turn left represent a abstractive description. So we have to give some abstractive description to formulate the goals. Then we'll see, after the goal formulation, the next step is the problem formulation. So what is problem formulation? It is a process of deciding what action and states to consider. So when we talk about any problem, and from that number of states we can take the number of actions. So the first step or the first process is to decide out of this which action and which state we have to consider. Example, driving. Suppose we have to drive from one city to another city. Here take the example from Amman city to the Jharkhand city. Suppose we have to suppose we have to drive, then which actions and which states we should consider. So in between states and actions are defined. So between this Amman state and between the Jharkhand state, which are the different actions that is to be taken, it is decided. Then states is what? Some places in Amman and Jharkhand. So in this Amman and Jharkhand, some places are there which are described by the states. Action: we can turn left, we can turn right, we can go straight, accelerate and brake, etc. So these are the actions. So in the problem formulation, we have to decide what will be my states, what will be my actions. And we have already decided the goal. Then next thing, search. Yes, search is very much important in the problem formulation. As we have already seen, there are suppose n number of ways to reach the goal. Then which path is best? It should be decided first. So because there are many ways to achieve the same goal, those ways are together expressed as a tree. So if there are 3 number of ways, then I'll draw a tree with 3 branches. those ways are together expressed as a tree format. So we convert the possible paths into the format of tree structure. Multiple options of unknown value at a point. The agent can examine different possible sequences of action and choose the best. The agent will going to examine the each and every possible path that can be taken by the agent, and then finally the agent will select the best one. This process of looking for the best sequence is called the search technique. The best sequence is then a list of actions called solution. So when we apply the searching technique, the best sequence which is selected using this list of action is nothing but the solution. Now the next one is the search algorithm. The search algorithm is what? It is defined as taking a problem and return a solution. Once a solution is found, the agent follows the solution and carries out the list of actions, that is execution phase. Of an agent means formulate, search and execute. So in the formulate phase, what we have to do? First we have to formulate the goal, then we have to formulate the problem. Formulate the problem means what? We have to decide what will be my states, what will be my actions. And once the goal formulation and problem formulation is done, we have to execute the search techniques, because it may happen that there are more than n number of possible ways. Then the agent has to decide the best way. Then once the best way or once the way is selected, then the agent has to execute that path. So now next one is well-defined problems and solution. What is the meaning of well-defined problems and solution? A problem is defined by 5 components: initial state, actions, transition model or successor function, goal test and path cost. So whenever we have to formulate the problem, that problem formulation is take place with this 5 components. So what will be my initial state, then what will be the possible actions, what will be the transition model or the successor function, means how we'll move from one state to the another state, that is transition between the states is nothing but the transition model. Then the goal test. Goal test means what? How we'll decide that this is my goal or not. Then the path cost. So these are the 5 components that we need to consider. Then next we'll see the well-defined problems and solutions. So a problem is defined by the 4 components. First is the initial state that the agent starts in. So always the agent will start from the initial state. Then the set of possible actions. Then the transition model, description of what each action does. This is nothing but the transition model. And then what is the meaning of successor function? It refers to any state reachable from given state by a single action. So suppose I am present at state A, then it refers to the state that will be reachable from the given state in a single action. So from state A, suppose in a single step I'll reach to state B, I'll reach to state C. So B and C will become the successor function for the state A, like this. So initial state, actions and transition model define the state space. The set of all states reachable from the initial state by any sequence of action represented as a state space. So if I am present at the initial state, then by taking n number of sequence of actions, if I am able to reach the states B, C and D, then A, B, C, D, this becomes my state space. A path in the state space, any sequence of states by a sequence of action. So suppose from A I'll move to B, then from B to I will move to C, then A, B, C will become my path. Then next one is the goal test. Goal test is applied to the current state to test if the agent is in goal or not. So when I move from A state to the B state. Then for every state we have to apply certain criteria to check whether I have reached to the goal state or not, and that criteria is called as the goal test. Sometimes there is an explicit set of possible goal state. Example in Amman. So there are some explicit set of goal states. Sometimes the goal is described by the properties instead of stating explicitly the set of states. So suppose it is asked that reach the Amman city, then it is example of a explicit. Then suppose it is decided that go to a city that contains this, that contains those, then this is the example of the goal is described by the properties. Example, chess. The agent wins if it can capture the king of the opponent on next move, that is checkmate. So this is the example of described by the properties, no matter what the opponent does. Then a path cost function. Now what is a path cost function? It assigns a numeric cost to each path. It is equal to the performance measure and generally it is denoted by G. It distinguishes the best path from others. Now what is the meaning of this? Suppose I were to travel from A to B, and if there are n number of possible ways, then I'll calculate the path of one way to the then second way, then the third way, and the path which cost least. If we talk about the traveling time, then the path which costs the least traveling time becomes my path cost function. Then usually the path cost is the sum of the steps cost of the individual actions. So if there are more than 2 actions, then the cost for the one action, then plus cost of the second action, then cost of the third action. So addition of this 3 path cost becomes my final step cost. So together a problem is defined by initial state, actions, successor function, goal test and the path cost function. The solution of a problem is then a path from the initial state to a state satisfying the goal test. So what will be our aim or what will be our solution? That we have to reach from the initial state to a state which satisfies the criteria for the goal test. And optimal solution is what? The solution with the lowest path cost among all solutions. So we have to explore all the possible paths, and the paths which is having the lowest path cost gives me the optimal solution. Then next topic is formulating problems. So till now we have seen what do we mean by the problem solving agent. Then we have seen how to formulate the problems, that is in the formulation of the problems we need to consider the initial state, then we need to consider the actions, transition model, successor function, then the goal test and the path cost. Now here we'll take the example of the Romania. Here on holiday in Romania, currently in the Arad city, the flight leaves tomorrow from the Bucharest. So the formulate the goal. Our goal is we have to reach to the Bucharest city and formulate the problem. Now here we have done the goal formulation. What is my goal? We have to reach to the Bucharest city. Now in the problem formulation, what we have to decide? We have to decide for states. We have to decide the actions. So the states represent the various cities that I'll encounter in order to reach my goal. And what will be my action? I'll move from one city to another city. So drive between the cities will be my set of actions. And then find a solution, a sequence of cities that is in between my initial state and the goal state, that is my source to destination in between cities represents my sequence of cities. So in this diagram, the map of the Romania is represented. Here the current location is Arad and from the Arad we have to reach to the Bucharest city with the path which is having the minimum path cost. Now we'll see the problem types. So the first one is deterministic, fully observable, implies it is a single state problem. Agent knows exactly which state it will be in. Solution is a sequence. So in this example, we know the agent is exactly in which city. That currently he is in the Arad city. Then when he performs the action, he will reach to the next city, then next city, like this. So every time the agent knows its location. So therefore this is the example of the deterministic and the fully observable. Then non-observable, sensorless problem, conformant problem. Agent may have no idea where it is. Solution is a sequence. So if the agent do not have any idea about its location, then the problem is called as the non-observable. Non-deterministic and or partially observable are nothing but the contingency problems. So percept provide new information about the current state. Often interleave search execution. So whenever the next percept sequence provides the new information about the current state, that problem is called as the contingency problem. And the unknown state space represents the exploration problem. So what are the different problem types? There are basically 4 problem types. That is, one is the single state problem. So when my environment is deterministic and fully observable. So in this we have seen the different problem types, that is single state problem. So whenever the environment is deterministic and fully observable, the type of problem is single state. Whenever the environment is non-observable, it is the conformant problem or the sensorless problem. And whenever the environment is non-deterministic and partially observable, or non-deterministic or partially observable, then the problem is contingency problem. And whenever there is unknown state space, the problem is the exploration problem. Now we'll see the example problems. As first example we'll see of vacuum world state space graph. So in this graph we are seeing there are two locations, A location and the B location, and in this squares dirt may be present or may not be present. So in order to formulate the problem, what we need the states, actions, the goal state and the path cost. So states represent what? It represents the integer, dirt and robot location. That is, it represents whether the dirt is present or not, and the robot location. Initial state, we can begin from any state. So any actions, the robot or the agent will move to the left or right or suck the dirt. Then goal test, what we want from the agent? We want all dirt should be clean, so no dirt at all locations. So this will be my goal test. Then what is path cost? Suppose the agent will move from one state to another state. Suppose we give the cost as 1 per action, then the addition of all the cost becomes the path cost. So here 2 locations are there, and from each location he can move to the left or right. So 2 into 2 raised to square, that is 8 possible world states are there. 2 locations, each of which might or might not contain the dirt. So 2 squares, in each square there may be dirt, there may not be dirt. So 2 into 2 states are there, and each step costs 1. So the path cost is the number of steps in the path in order to reach the goal. Now we'll see the second example problem as the 8 puzzle. So now here we can see the start state and the goal state. So we have to start from the start state and we have to reach to the goal state. So now we have to formulate the problem for this. So we have to finalize what will be my states, what will be action, what will be the goal test, and path cost. So here the states represent the location of the tiles, and actions move blank. We have to move the blank slide, so or blank tiles. So move blank left, right, up and down. These are the possible actions. And the goal test is my goal state which is given, and the path cost is 1 per move. Now in this example there is a 3x3 board with 8 numbered slides. As we can see, the tiles are numbered from 1 to 8. So 3x3 board with 8 numbered tiles and a blank space. A tile adjacent to blank space can slide into space. So 9 factorial divided by 2. So it is equal to 181,440 reachable states. So this many reachable states can be possible in this example. Now the next example is of robotic assembly. So if you see this diagram represents the robotic assembly. So again here we have to decide states, actions, goal test and the path cost. So for the robotic assembly, the states is nothing but the real valued coordinates of robot joint, angles, parts of the objects to be assembled. And what will be the actions? Continuous motions of robot joints. So there will be continuous motion of the robot joints. Then what is goal test? The goal test is the complete assembly. So whenever there is a complete assembly of the robot, it is said to be in a goal test. And what will be the path cost? We have to execute this particular robotic assembly in less amount of time. So time to execute represent my path cost. Now the next problem is using only 4 colors, you have to color a planar map so that no two adjacent regions have the same color. Now this kind of problems can be asked in exam. The example is given and you have to formulate the problem for this. Now this particular problem is asked many times for 5 marks. So what we have to do in this, we have to use only 4 colors. And you have to color a planar map so that no two adjacent regions have the same color. Now for this initial state, what can be my initial state? The planar map with no regions colored. So initially the planar map with no colors. Then what will be my goal test? The goal test is all regions of the map are colored and no two adjacent regions have the same color. So this criteria is already given in the problem and that is my goal test. Now what will be the successor function? Choose an uncolored region and color it with a color that is different from all adjacent regions. So what action I should take? First I have to look for one uncolored region and then I have to look for its adjacent region. And then I have to select the color which is not present around that particular region. Then I have to paint that color using that color. So what will be my cost action? The cost action could be 1 for each color used. Then the addition of all colors will be my cost function. Then we'll see the 8 queens problems. We already, all of you know the 8 queens problems. So for the 8 queens problems, there are 2 ways to formulate the problem. All of them have the common followings. The goal test is what? 8 queens on board and non-attacking to each other. And the path cost is 0. Path cost is of no interest because only the final state counts. So in the 8 queens, the path cost is no important. We only want the goal test where all 8 queens are present on the board and in the non-attacking position. So now here first we'll see the incremental formulation. So there are two ways to solve this 8 queens problem. The first way is called as the incremental formulation and second one is called as the complete state formulation. So first we'll see the incremental formulation. So incremental formulation involves the operators that augment the state description starting from an empty state. So it involves the operator that augment the state description which starts with the initial state, that is the empty state. Each action adds a queen to the state. So in action we have to add the queens onto the board and we have to place such that no queen will be in the attacking position. So what will be the states? Any arrangement of 0 to 8 queens on board. Then what will be the successor function? Add a queen to any empty square in the non-attacking position. So in this way we can formulate the problem. Now there is also a second possible way to solve this problem and that is called as the complete state formulation. It starts with all 8 queens on the board and then we have to move the queens individually around. So here the states can be any arrangement of 8 queens, one per column in the leftmost columns, and the operators are move and attack queen to a row non-attacked by any other. So in the first problem we start by placing one queen, then second, then third queen in position. In the second type of solution, what we are doing, we are starting with all the 8 queens which are present on the board. Then we move the queens individually so that there will be no attack. So the conclusion of this is the right formulation makes a big difference to the size of the search space. So when we formulate the problem properly, it will result to the less size of the search space. Then the next one is we'll see the searching for solution, how to search the particular solutions. So finding out a solution is done by searching through the state space. So we are having the number of states, so which we search through all the possible states. All problems are transformed as a search tree generated by the initial state and the successor function. So we represent the problem in the form of a tree and then we apply the searching techniques on that problem and we reach the solution or we find the solution. Then in search tree what we are having? Again we are having the initial state, that is the root of the search tree is a search node. So the root of the search tree represent the search node. Then what is the meaning of expanding? Applying the successor function to the current state. So we have to apply the successor function to the current state, thereby generating a new set of states. So if we apply the successor function to the current state, then it will generate the new set of states. Then the leaf nodes. Then the next one is the leaf nodes. The states having no successors. So if you imagine the tree structure, in the tree structure we have having the root, we are having the branches and we are having the leaf nodes. So similarly here we are having the initial state, then we explore the initial state into the different branches and at the last we reach to the leaf node which doesn't have any successor. Then fringe is what? Set of search nodes that have not been expanded yet. So if the node is not expanded yet, it is called as the fringe. Now, here we'll see the tree search algorithms. So now what is a tree search algorithm? The basic idea is an offline simulated exploration of state space by generating successors of already explored states, that is expanding states. Here program for the tree search. The function name is tree search and the input is given as the problem and the strategy that can be used to solve that particular problem. And what it returns a solution or a failure. Initialize the search tree using the initial state of a problem. So we have to initialize the search tree, or we have to always start from the initial state of the problem. Then what we have to do? We have to do this in a recursive manner. Therefore, it is represented in loop do. So what are the rules? If there are no candidates for expansion, then return failure. If there is no candidate of or if there is no node for the expansion, then we have to return the failure message. Choose a leaf node for expansion according to strategy. So every time we have to choose the leaf node and we have to expand that leaf node according to the strategy decided for that particular problem. If the node contains a goal state, then return the corresponding solution. So whenever we are exploring the nodes one by one, always we have to check whether this node is a goal node or not. And if we reach the goal node, then we have to return that node as a corresponding solution. Else we have to expand the node and add the resulting nodes to the search tree. So we have to continuously append the search tree. So here the Romania city example search is shown. So we have already seen that in that diagram we are having the initial state or the source is Arad city. So the root node is here the Arad city, and for in that map from the Arad city there are three possible paths. So here you can see there are three branches. Then from the Arad city to the next city, suppose there are four possible paths. So in the left hand side you can see from that intermediate node there are four branches like this. So from the Arad city we can reach to the Cebu city. Then from Arad city we can reach to the Oradea city. From the Arad city we can reach to the Timozara city. So three possible ways. So we have explored the Arad to three branches. Then suppose in the next step there are four ways from to reach the another states from the Cebu. Then there are four branches are shown. So from the Cebu states we can reach to the four state, that is we can again go to the Arad, we can go to the Fagu state, we can go to the Remsku Valia, we can again go to the Ordia state. So we have to look for the map and we have to check from this city we can reach to which city, and according to we have to explore the search tree. Then in the search tree what we have to consider? The essence of searching in case the first choice is not correct. So if my first choice is not correct, then my whole process gets wrong. So choosing one option and keep others for later inspection. So we have to check all the options one by one. So go for the one option and then keep the other for the later exploration. Hence we have the search strategy. Therefore the strategy is needed which determines the choice of which state to expand. So we have already seen the example. So from Arad city we can reach to three different cities. So which determines the choice of which state to expand? We have to expand the Cebu city or we have to expand the Remanike city. So this depends on the search strategy. So if we select the good choice, then it will lead to fewer work and it will lead to the faster execution or the faster solution, and we always interested in the fewer work and the faster solution and the optimal solution. Then what is important? The state space is not equal to a search tree. Now what is the state space? Here the state space has unique states A and B, while a search tree may have cyclic paths, that is A to B, A to B, A to B. So as we have already seen in that diagram, from Arad to the one more city and then from that city again to Arad. So there may be cyclic paths. A good search strategy should avoid such paths. So if my goal is to move from one source to another destination, and if I'm taking the action that, suppose presently I'm at A location and I want to reach to the Z location, and in between suppose I took a path that is from A, I will move to the B, then there is no point for moving again B to A. This will not lead to the solution. So a good search strategy should avoid such paths. The cyclic path should be avoided. A node is having 5 components. Now what the node has? It has the state, then parent node, action, path cost, and the depth. So what is state? Which state it is in the state space. So the current state in the state space. Parent node, from which node it is generated. So the initial node is my parent node. Path cost, the cost, it is generally represented with G. The path cost G of n from initial state to the node n itself. So from initial location to the nth node, what will be my path cost? So the addition of all the costs represent the path cost. Then action, which action applied to its parent node to generate it? What action I should apply to the parent node to generate the next node? It represents the action. Then depth, the number of steps along the path from the initial state. So in the search tree, we explore the tree depth by depth. So from root node, suppose we explore once, then that is depth 1. Then from that node, suppose I explore again once, so that will be my depth 2. So the level of my exploration represent the depth for that particular tree. So now implementation, states versus node. So a state is what? A state is a representation of a physical configuration. A node is what? A node is a data structure constituting part of a search tree. It includes state, parent node, action, path cost, g of x, and depth. So state is what? It is just a physical configuration. And what is a node? A node is nothing but a data structure. And this data structure contains state, then parent node, then action, then the path cost and depth. Path cost, here it is written as g of x. So if my present state is x, then the path which is required, the path cost which is required from initial state to the x state represent the total path cost for that x state. So that is represented as g of x. So in this diagram we can see for this tiles a node is represented, depth is equal to 6, therefore the path cost is equal to 6. So for one particular tile we can represent its node data structure. The expand function creates new nodes, filling in the various fields and using the successor function of the problem to create the corresponding states. So the expand function, what is the function of this expand function? It creates the new nodes, filling in the various fields and using the successor function of the problem to create the corresponding states. So in the search tree, we have to look for the initial state, then we have to apply the search strategy, and one by one, depth by depth, we have to explore the search tree. Then we have to examine each possible branches of that tree. Then we have to calculate the path cost. Now what is the path cost? The cost of root node to the leaf node. The addition of all these branches is nothing but my path cost. Then we have, out of this n number of possible branches or paths, we have to select the path which has the least cost. So in this way, the solution is found for the search problems. Now we'll see what is the meaning of the search strategy. So a search strategy is defined by picking the order of node expansion. So we have to decide the order of node expansion. I have to explore which node first, then which node later. This is to be decided under the search strategy. Then strategies are evaluated along the following dimensions. So what we need to consider when we decide the strategy? We need to consider completeness, time complexity, space complexity, and optimality. Now here, what is the meaning of the completeness? Does it always find a solution if one exists? So if we are solving a particular problem, and then we have to check, if I apply this search strategy, then this search strategy always finds a solution if the problem solution actually exists. If it satisfies this criteria, then we can say that that particular search strategy is complete. Then what is time complexity? Number of nodes generated during the search. If we explore the branches, then what number of nodes are to be generated during that search represent the time complexity, because to explore each and every node we require the time. So the total time in order to explore the number of nodes need to be considered. Then space complexity, maximum number of nodes stored in memory. So whenever we are executing any search strategy, we are exploring the number of nodes, then we need to store this explore nodes somewhere. So the maximum number of nodes that are required to be stored in memory till we found the solution, that is represented using the space complexity. Then next one is the optimality. Does it always find a least cost solution? Yes, this is very important. Whenever we have to decide any search strategy, we have to check whether the solution is the optimal or not. So if the search strategy always give me a solution, but is that solution optimal? Is that solution contains the least cost? This is again a very important criteria. So whenever we have to decide a strategy, we need to focus on this important characteristics exhibited by the search strategy. Whether that strategy is complete, what is the time complexity of that strategy, what is the space complexity of that strategy, is this strategy will give me an optimal solution or not. Next one is time and space complexity are measured in terms of maximum branching factor of the search tree. This is represented using the B variable. So what is the meaning of maximum branching factor of the search tree? It represents the maximum number of successors of any node. So if I explore one node, then what will be the maximum successors of that node? Means what will be the maximum number of children explored by that node represent my maximum branching factor, that is B variable. Then next one is depth of least cost solution. Now again we have to check this, that is whenever I am interested in the least cost solution, then what is the depth that need to be explored by that search strategy in order to reach that least cost solution, that is the shallowest goal node. This d represents, the d variable is used to represent the depth of the least cost solution. The next one is maximum depth of the state space may be infinity. This variable can take a infinite value. So the time and space complexity are measured in terms of these three variables: maximum branching factor B, the depth of least cost solution D, and the maximum depth of the state space, that is M. Then we talk about what is the search strategy and what we need to consider while selecting the search strategies, how the time complexity and the space complexity is to be measured. Now we see what are the different search strategies are there. So basically there are two types of search strategies. One is the uninformed search or blind. What is uninformed search? Whenever there is no information about the number of steps or the path cost from the current state to the goal state. When we don't have the information about how many number of steps are required or what is the path cost from the current state to the goal state, then the search technique is called as the uninformed search or blind search. So we are taking or we are applying the search techniques in the blind manner. This search strategy is applicable when we only distinguish goal states from the non-goal states. So here basically what we are doing, we are exploring, we are continuously exploring the branches and we are exploring the nodes, and for each node we are testing whether we have reached the goal state or not. If it is a goal state, then return the solution. If it is not a goal state, then go for the exploration. Search the state space blindly. So whenever there is no information and we are exploring the search tree blindly, it is called as the blind search or the uninformed search. Then the next technique is called as the informed search or heuristic search. In this technique, a cleverer strategy that searches towards the goal. Now, as compared to the uninformed search, this strategy is a clever strategy which searches towards the goal based on the information from the current state so far is applied. If we have some knowledge of the path cost or the number of steps between the current state and the goal state. So here we are having somewhat information about what the number of steps it will take to reach to the goal state from the initial state. What can be my path cost to reach from the initial state to the goal state? Then this information is used in a intelligent manner, in a clever manner to apply the searching techniques. So basically these are two searching techniques. Then in the next video, we'll see the various searching techniques, that is uninformed searching techniques and the informed search techniques. So in the uninformed search techniques, we are having the best first search, depth first search, then the depth limited search, depth first iterative deepening, and in the informed search techniques, we are having the A* search. So now just we'll revise what we have seen in this particular video. So in this video, we have seen the problem solving agent. So whenever we have to solve any problem or whenever we have to solve any particular task, we use the agent to solve that problem, and that is the problem solving agent. And here, instead of the reflex based agent, we use the goal based agent because we are interested in finding the goal. So the problem solving agent is a goal based agent. Then in the problem solving, first we have to formulate the goal. So you need to consider what will be my goal. Then after goal formulation, the next step is you have to follow the problem formulation. So in the problem formulation, what we do? We do the selection of the states and we select the actions. What can be the possible states? What can be the possible actions that you need to decide in the problem formulation. Then you have to apply the search method on that. So a well-defined problem and solution has the 5 components. It has the initial state, that is we always starts in the initial state. Then from that initial state we took the actions, then transition model, the successor functions, then the goal test, then the path cost. Goal test is what? The goal test is the criteria which is used to check whether we have reached to the destination or not. Then path cost is what? The path cost is the addition of all the cost of all the intermediate states from initial to the goal. So whenever they ask you to formulate the problems, when given a problem, what you need to consider? You have to decide the goal, you have to decide the states, you have to decide the actions, then transition model or the successor function. Then we have seen the example problems. Here we have seen the example problem of vacuum world. Then we have seen the 8 puzzle problem, then robotic assembly, then the planar map color problem, then the 8 queens problem. Now in the 8 queen problem we have seen 2 ways to solve the problem, that is incremental formulation and complete state formulation. So it may happen that to solve the particular problem there may be number of ways possible, but whenever we have to select the problem strategy, you can explore or you have to explore all the possible strategies, all the possible methods, and you have to select the best one. Then we have seen the tree search algorithm, how the tree can be expanded with the help of that Romania Sitica example. Then we have seen in order to consider the best search strategy, you should focus on the components such as whether that search strategy is complete or not, what is the time complexity of that strategy, what is the space complexity of that strategy, and whether that strategy will give me optimal solution or not. Again, the time and space complexity is measured in terms of maximum branching factor, depth of the least cost solution, and the maximum depth of the state space. Then we have seen the search strategies, basic search strategies types, that is uninformed search or blind search, and informed search or heuristic search. Now blind search means what? We don't have any idea about how many number of steps it will take to reach the goal from the from the initial state or the source, or what will be my path cost. This information is not known, and blindly we apply the search techniques, we explore the paths. Therefore it is called as the uninformed search or the blind search. Then informed search means what? We have the idea about how many number of steps it will be taken to reach the goal state from the initial state. Then what will be my path cost? Approximate path cost is known in advance. So we apply this available information and we apply the search techniques in an intelligent manner or in the clever manner. And the available information is given to the search strategy as a heuristic function. Therefore, this information search method is also called as the heuristic search method. Now, in this, we can have the various examples. The problems that can be asked from this topics is explain the problem solving agent with the help of example. So you need to explain what is the problem solving agent. Then you can give any example. You can give 8 queens problems or the Romania city problem, or you can give the example of a water jug problem, or the There might be the questions given as the problem definition is given, that is such as the 8 queen problems or the 8 puzzle problem, and you need to formulate the problems. So formulation of problems means what? You need to identify the initial state, then the goal test, then the path cause, then the action, transition model, and the successor function. So from these topics, these questions might be asked. Hope this video is helpful to you in understanding the concept of the problem solving agent, then how to formulate the problems, and how to write down the problem formulation for the given examples. Thank you.